Get started. Okay, welcome back. Hope we had a great weekend. First thing has nothing to do with our class, but it's just an announcement for you guys. If you have any interest in possibly transferring to another school after you leave GCC, there is a wonderful event here on campus today, October the 9th, between 10 a.m. and 1 p.m. It's the Transfer Fair. It is not uncommon for local colleges to come and send a representative, and so sometimes down in the core, when you walk into the main entrance, there'll be one school that has some folks there and can answer your questions. What is uncommon is to have 50 schools here answering questions for you. So today, and today only, let's see, Smith, Mount Holyoke, Amherst, they'll have special presentations, and then here is a long list of colleges that will have representatives here on campus today. So again, a really great opportunity today and today only from 10 until 1. It's in the dining commons. So go if you have any interest in transferring at some point, even if you're not sure. It's a great way to get information. Any questions on this? Okay, so that is that. Let's come over here and we'll take a look at our calendar. So we just came back from the test. It feels like forever ago, but we had our test on Thursday. I have graded the tests. I will give them back at the end of class today, and we'll talk about them later. For right now, we move on to something called weighted voting systems. We're going to spend 2 days on this topic of weighted voting systems. And even though it's got the word voting in it, it really is quite a bit different from all the voting stuff that we just finished. And we'll talk about the differences. And then after those 2 days on weighted voting systems, what's happening October the 16th that's important for you? What is due on October the 16th is not the project itself, but a plan for the project. This is your way of committing to one of the project topics. They're all in the back of the packet. I want you to have read the information about the projects, decided which one you're going to do, and at least just kind of started thinking about sources if you're going to be writing a research paper, and if you're going to do your own election, what the question is that you're going to ask and how you're going to find 20 people to poll. So that is due 1 week from today. Okay? All right, so we start a brand new packet today. It looks like this. I just put one on everybody's table, so go ahead and grab this. We're not going to be using the first packet anymore except to talk about the projects, so you don't need to keep bringing the first packet with you every day. This packet number 2 is going to be all the material for test number 2. There are a few reference sheets on the first couple of pages. We're just going to skip over them for now, and we'll come back to them as we need to. So we start on page 7. And starting on page 7, we need to begin by discussing the Electoral College, and what a great time to talk about the Electoral College. So who can share some stuff that they know about the Electoral College? Lucas.
What they feel is a good position, but plus the reason for it is like it's more educated than the average person would be about certain things, so they feel like they represent better than they look themselves.
Okay. Other things to add? Thank you.
Well, each state has a certain amount of electoral votes. So I mean, say Romney, Obama only wins Massachusetts by 1 vote. They still would get all of Massachusetts electoral votes.
Okay, so let's start talking about this idea of electoral votes. When you go out and vote on November the 6th, and you are going to go out and vote on November the 6th, yes? Yes, yes, yes. Are you going to directly vote for the president? And the answer is no. You are not directly voting for the president. As Tim points out here, if Obama wins the popular vote in Massachusetts by 1, then he will get all of Massachusetts's electoral votes. So we've got this picture up here with some numbers in it. So let's take a look at this picture. First, I'm going to scroll down. Actually, I want the second picture first. So here is a picture of the results of the 2008 presidential election. Obama and McCain. You can see Obama won the states in blue, McCain won the states in red. Here, Massachusetts had 12 electoral votes in that election. And it doesn't mean that everybody in Massachusetts voted for Obama. It just means that more people voted for Obama than anybody else. And by getting more of the votes than anybody else in Massachusetts, Obama gets every one of those 12 electoral votes, which is kind of interesting because, as Tim says, if Obama wins Massachusetts by 1 vote, he gets all 12 of these. It would be like us saying, okay, let's take a vote every day about what kind of ice cream we want. And let's say that chocolate beats vanilla every day by 1 vote. What are we going to have every day? Chocolate every single day, even if basically it's a half and half. But chocolate wins by 1 vote. Every single day we have chocolate. This is a winner-take-all system. I'm not judging it. I'm just pointing out exactly what Tim had said. You win by 1 vote, you get all of the votes. That's true in most states. Do you see something quite funny happen in 2008? Mike? That's absolutely related. This is the funny thing I'm talking about, is the one in the blue circle. All right, first of all, what state is that? We know our geography. What is it? This is Nebraska. Nebraska has a total of 5 electoral votes. Most states is a winner-take-all, like Massachusetts has 12, winner-take-all. Nebraska actually has different congressional districts. They have 3 of them. And you can win 1, 2, or all 3 of those congressional districts as a presidential candidate. And Obama's camp was worried that there might be a tie in terms of the whole state, the whole country, and this election. So it turns out there are a total of, does anybody know how many electoral votes? So it's 568, all right? Nope, 538. Does anybody know, like at the bottom of the screen, when it comes to election day and they start recording like how many electoral votes have gone each way, there's a number that you need in order to win the whole election as president. Does anybody know that number? It's 270. The number 270 is going to be on the bottom of all these screens when they start tallying the votes. You need 270. The reason is, well, it feels like 270 is going to be more than half, right? So half is actually, lost my number here. 538, half of 538 is how much? 269. So it turns out there could be a tie. There are a total of 538 votes up here in this picture. So it could be dead tied. 269 to 269. So when they say you need 270 to win, that's our way of making sure it's not a dead tie. So you have more than half. And Obama's camp was worried that it might be a dead tie at 269 to 269. And so he campaigned really hard in a typically Republican state, and he won that congressional district, and he won that 1 vote. And that was their kind of safety net to make sure that if it was going to be a tie, that he would actually pull out the victory. It turns out it wasn't really all that close. But anyway, that is kind of a funny thing that happened in Nebraska. Okay, so that is that. And let's go. The states decide whether they're going to split. Most states are winner take all. I believe there are 3 different states that have this kind of funny thing. Because, yes, that's right. So can you guys look up and find the state with the most votes? Yeah, California's got 55. How about second? Looks like Texas down here with 34. Third? New York has 31. Fourth? Florida's got 27. Okay, so these are the, quote, powerful states. The reason we're talking about all this stuff in a math class is that we are going to really analyze precisely how powerful is California and Texas and Florida. I see all these numbers. For example, I see 55 for California. What state is up here in the Northwest? Washington. Is it fair to say that California is 5 times as powerful, right? 55 to 11, 5 times as powerful. That's the kind of question that we're going to be concerned with. That's why we're talking about this in a math class. How much more powerful is California than Washington or than Massachusetts? So yeah, these numbers are not constant. Let's take a look at this map, which is the new numbers. I don't know if you remember, how many votes did we have here? We had 12. We now have 11. What happened? The population went down. How does the U.S. government know the population went down between 2008 and 2012? We had a census. You guys remember? Back in 2010, we had a census. So hopefully you guys all filled one out, or maybe if you're living at home, your parents filled it out and said, yes, so-and-so lives with me. And they got an updated count in terms of the population. And some of these electoral votes moved around. The states in orange, including us, lost votes. The states in blue gained votes. I think Texas was at 34, right? Now they're at 38. So yes, it has a lot to do with population, and every time we have a census, some of these numbers move around. It's not going to change next election. I think it might have said something like that on the, here it says 2012, 2016, and also 2020, because it's not an instantaneous count. It takes some time to analyze all that data. So for the next 3 elections, it'll be those numbers. Okay, so we've got that. First picture. Okay, so let's talk again about this idea of a direct vote. I said that we are not voting directly for the president. We're voting to tell certain electors that are here in Massachusetts, here's how we want you to vote. And it turns out that there are some elections where a candidate wins the popular vote, meaning they have more votes than anybody else, but loses the election. This happened 3 times in our history, back in 1876, 1888, and quite recently in 2000. Who won the 2000 election? George Bush. Who had more votes than George Bush in terms of the popular vote was Al Gore. But the presidency is not determined by popular vote, it is determined by electoral votes. And so that was a moment where the person who got more votes than anybody in terms of people voting for him did not win the election. And then if we come down, there are just one more graphic I want to point to. This is a graphic representing information from the 2004 election, George Bush and John Kerry. And the top picture is supposed to give us a sense of how often those 2 candidates visited each state. In the last 6 weeks before the election, every one of these handprints represents a stop, a campaign stop by either George Bush or John Kerry. And you can see that, let's see, so in the last 6 weeks in California, they got 2 visits. I don't know if it was one each or if it was the same person twice. Which way does California generally vote? Democrat. They did not get a lot of attention in the last 6 weeks of this election because both parties said, hey, this is going to go to the Democratic candidate. It doesn't matter who's running, right? And Massachusetts over here, it's hard to see because Pennsylvania is covering us up, but Pennsylvania got a whole lot of attention in the last 6 weeks of that election. We didn't get any. Down here, Florida, you can hardly see. It's just like filled blocks. We've got Ohio there. What is the name we give to the states that get all this attention? Those are the swing states. Typically, a lot of states either are always Democrat or always Republican. And so what's the point in spending time and other resources for these candidates in the last 6 weeks leading up to the election? They put all of their eggs in one basket, the swing states, the states where it's not really clear which way it's going to go. Same kind of idea down here. This is the same election. Every dollar sign represents $1 million spent in advertising in the 6 weeks before the election. Again, Massachusetts, not a whole lot of attention, but you can see the same kind of thing happening, Florida, Pennsylvania, Ohio, in the swing states where they put all of this money, millions and millions of dollars. So I have a friend that lived here and is now living in Pennsylvania, and she says that the difference between the advertisements on TV here and over there is just, it's night and day. She says it's all the time with these advertisements in Pennsylvania because it's a state that could go either way. And so the candidates throw all this money, all this attention to these swing states. I kind of feel like we could use a little more attention here. I don't know. Just I feel like I'm left out. And I think a lot of states, you can see how blank the landscape is, right? Most states are left out. Okay, so let's come back here and we will just have somebody read this Wikipedia thing. Nicole?
What is the election?
You can skip to the next part.
From Wikipedia, argued that electoral college is biased, inherently undemocratic, gives certain disproportionate. Opponents argue both college and should feature
Thank you. Okay, so I'm trying not to judge. I'm just giving you some information, some facts. There are some pros and there are some cons to this electoral college. It is what it is, but I think it's important for us to kind of understand what it is, especially at a time like this, heading into a really big presidential election. Okay, so let's go to number 2, Mary. Thank you. So I know we're still using the word vote and voting, but I want to really make it clear this is a different kind of thing than what we've been studying the last month. When we were conducting elections, how many candidates did we have? Sometime. You just throw out a number. 4 candidates, 3, 5. We had a bunch of candidates, right? Okay, I know there are a bunch of candidates running for president, but really, how many people? How many men? There are 2 people, right? We can guarantee right now that one of 2 people is going to be sitting in that Oval Office, come January, whenever they swear in or reaffirm the president. So there are 2 choices, and that is one of our distinguishing features for a weighted voting system. It is not a rank A, B, C, and D. It is pick. You pick one. You have 2 choices. Pick one. And so oftentimes we're going to talk about these things as being like yes or no. You're either for or you're against. But every single time it's going to be 2 choices. And the other thing that makes it a weighted voting system is that we don't each have 1 vote where we're all equal. Some states have more power than others. California has 55 votes that are either going to be a yes or a no. And so it is quite a bit different, I think, than all the voting that we've been talking about so far. So let's come down here to 3. We'll go to Grace. Okay, so our weighted voting system here, you're going to have a bunch of inputs, a bunch of things given to you. First of all, you need to have some different stockholders or states. They also need to have a certain number of votes. California has 55 votes. This first person has 10 votes, second 9, last one 3. Can we look at that and decide who the most powerful person is? Pretty clear, right? Who's the most powerful? 10, and then 9, and then like really, really not powerful at all is the 3, yes? Turns out it's not always clear. In fact, you can't, the question that I asked does not have an answer. You can't just look at 10, 9, and 3 and tell me who the most powerful person is until I tell you what we need in order to pass something. You need to know what the quota is, a certain number of votes that will make the motion pass. For example, how many votes are there total? There are 22 different votes here, yes? Suppose that I told you that in order to pass something, we need 22 votes. What's the only way to make something pass? Is if all 3 of them say yes. Agree? If we require all 3 of them to say yes, is it true that 10 is more powerful than the 3? No. How is the power distributed in that case? They're all equal. Yes? They're all equal. If we require 22 votes, then they're all equal. So it is not a good question that I asked the first time. We can't just look at 10, 9, and 3 and say, oh, 10 is the strongest, and then 9, and then 3 has hardly any power. We also have to think about this idea of a quota. All right, so here's some notation. It says we denote a weighted voting system with all of this stuff. So this is just something you're going to see in the book, and you'll practice, and it'll become easier. You put brackets. Q is the quota. How much is the quota in our case? It's given as 12. I had it as 22 a second ago, but let's write it as a 12. And then you list the number of votes that each person has in decreasing order. 10, 9, 3, and then you put the bracket. So go ahead and write that down. That's our compact way to talk about this weighted voting system. Okay, now there's some vocabulary that you're going to look up in your book. You might have already read some of it over the weekend or last night. Dictator, veto power, and dummy. There's going to be homework on it, but it's just vocabulary, so take a look at it. We move on to number 6. We'll go to Tim.
What is a coalition? A group of players that get together for a coalition system.
Okay, so we're going to go to 7. List all the coalitions from players P1, P2, and P3. So just 3 different people. And the question is, how can they get together and vote yes? Let's just say they're voting yes. So on the one hand, you could have just P1 as the only person voting yes. What other single ways can we have people voting yes? Just just P2 voting yes, or just P3 voting yes. That's all the ways that a single person can vote yes, and then the assumption is that the other folks are voting no. So these are the singletons, but they're also pairs. Can you guys write down all the pairs of people? Write down every possible combination of pairs. How many pairs did we find? Hopefully we've got 3 pairs. 1 with 2, 1 with 3, 2 with 3. And then there's finally one other way to vote yes. What could it be? There's all 3 of them. So maybe they are all in favor, so they all vote yes. So we list the singles, we list the doubles, we list the trios. If there were 4 people, we list the quads. So each of these things is called a coalition. It's just a way that people can band together and vote the same way. Let's just say it's called yes, okay? How many different coalitions were there? 7 coalitions. So it's a math class. We like to count things and look for patterns. Next question says, if there are 4 players, how many possible coalitions are there? So you could list them out, but I want to save a little bit of time. Can we go back to the very first page of this packet? Actually, where is it? Here we go. Sorry, page number 3 in this packet. So in page number 3, you can see here the list of things that we just wrote. Yes, that's all the coalitions with 3 people. And then if we have 4 people, let's see, so then there's 4 singletons. There are a whole bunch of pairs, a whole bunch of trios, and then one way for them all to vote yes. How many coalitions are there? Let's just count them. 15? Yes? Okay. So let's see, we'll write this temporarily. Let's see, there are 7 ways to do that. There were 15 ways to do that. I'll tell you that the next number in this list is 31. If there are 5 people, it turns out there's 31 different coalitions. Anybody see a pattern? Double and plus 1? We see that pattern? 7 doubled is 14 plus 1. 15 doubled is 30 plus 1. Yeah, that's good. Here's another way to see this. If you take 2 and you raise it to the, how many people were in this top one? There are 3 people. What do you get? How much is 2 cubed? That's 8. Subtract 1, it's 7, yes? Let's see if the same thing happens down here. 2 to the, how many people now? 4. What is 2 to the 4? 16, subtract 1, 15. Let's try one more. 2 to the 5, how much is 2 to the 5? 2 to the 5th is 32, and then subtract 1 is 31. Good? So absolutely double and then add 1 works. The reason that I like thinking of it as a 2 to the power and then subtract 1 is that you don't need to know all the numbers in the list to get the last one. Right? If you're thinking, okay, double and then add 1, and I wanted to know how many coalitions with 10 people, it's way down in this list, right? Well, to get that number, you need to know the previous number. And to get that number, you need the previous one as well. So this way, I could just go down to that 10th number right now. If there were 10 people in my group, what would the formula be? 2 to the 10th minus 1. And I could just type that into the calculator and have it in one shot without having to do first 9 calculations. So I think we can write that as a formula here. So if there are n players, it's 2 to the n, subtract 1. So we're back on page 6. Okay. Now in number 9, there's some more vocabulary that you're going to look up talks about winning and losing coalitions, talks about the grand coalition, and then it talks about this thing called a critical player. And that is going to be the critical definition for today. So we're going to use that phrase over and over again. We're not even going to write down a definition, but hopefully it will become clear what we mean by that when we do this big calculation. So let's go to number 10, where we consider that stockholder example. It was a quota of 12, and we had 3 players, 3 voters, who had 10, 9, and 3 votes, respectively. And we're just going to call the players P1, P2, and P3. Instead of giving them names, we'll just treat them as kind of these abstract things. And so here's what we're going to do. We're going to list, first of all, we're going to list all the coalitions. And so I'll put in here exactly the same list that we had up above, starting with the singles. Could just be P1, could just be P2, could just be P3. Then go ahead and list the doubles. And then finally the 1 triple. So fill it in. We should add 7 spots for all 7 of the things that we had up above. So we've listed all the coalitions. Any questions so far? And again, let me be clear, the goal is to figure out how powerful each of these people is. Are they all equally powerful? Does the 10 have all the power and nobody else has any power? We're going to try to figure out how powerful each person is. And again, the idea is then to take this concept and apply it to the states with the Electoral College. How powerful is California? How powerful is Massachusetts? Okay, next thing we're going to do is we're going to fill in the total weight for each coalition. I'm going to start right here, and I'll fill 1 in, and you guys will fill in the other 7. P1 is the first player. I'll put it up here. This is P1, that's P2, and that's P3. If P1 and P3 band together and they both vote yes, how many votes do they have total between them? It's 13. Does everybody see where we got 13? So their weight is 13. So P1 and P3, P1 has 10 votes, P3 has 3 votes, 13 altogether. So with the people at your table, can you fill in the rest of that column? We're looking for combined weight for each coalition. Okay, so just double check me. Did I get this right? Okay, so next thing to do is to decide whether or not each coalition is winning. Remember, the quota here is 12, which means to win, you need 12 or more. Is this 10 a winning coalition? Nope. Just put a big N. Yeah, about the 9? Nope. The 3? Nope. How about the 19? Yes, 12 or more is winning. So 13 is good. Then we get to this 12. It's a tie. So again, I got to be really clear. 12 or more is winning. So 12 is enough. Right? You just have to get to the quota. You don't have to beat the quota. You just have to get there. And then, of course, 22 is enough. Okay, next thing. The only coalitions that we care about are going to be the winning coalitions. So I'm just going to kind of put a big X through all of these losing coalitions. I don't need to worry about them. In fact, I didn't even really need to write them, and we won't write them on the next page when we do the next calculation. So we only list the winning coalitions. And then here's what we do. We ask ourselves if a certain player is critical. This is that yellow highlighted critical player business. I haven't defined it, but let's define it right now. So we're going to look at P1 and try to decide if P1 is critical. So to decide whether or not P1 is critical, what I'm going to do is temporarily take them out of this mix. If P2 is there by themselves, how many votes do they have now? They now have 9 votes. Is that enough to win? No. So was P1 critical to the success of this coalition? Yes, that makes them critical. So right over here, we're going to say, yes, P1 is really important in this coalition because without them, it goes from winning to losing. And then we play the same game with P2. We're asking ourselves, is P2 critical? I don't know. Let's temporarily cross them out. How many votes does this coalition have now with only P1? Has only 10. Is that enough? No. So is P2 critical? Yes, because without P2, we lose. P2 is critical to the success of that coalition. So we put P2. Okay, so Patty is willing to say that everybody's critical from this point forward because it feels like we need them to be in there to win. And if that's true, then yes, they're all critical. So let's look at the last coalition for just a moment, and then you guys are going to work together to fill in the rest of this table. Suppose I come down here and I ask myself if P1 is critical. So I'm going to temporarily cross off P1. So all that's left is P2 and 3. How many votes do they have altogether? They have 12. Is that enough to win? Yes. So was P1 critical? No, we could do without P1 in this group and we still win. So P1 is not critical. At no point do you do this. At no point do you start crossing off more than one person. This is a person by person test. You cross them off one at a time and then you bring them back, okay? All right, so with the people at your table, can you guys fill in the last of the 3 blank spots over there? Yes. So I think what we found is that in the first few rows, everybody's critical. So that's P1 and P3 are both critical. P2 and P3 are both critical. Here's the tricky one. Who's critical in the last coalition? Nobody, because you can do without. Let's take a look, for example, at P3. I'm going to temporarily cross them off. If I take away P3, do I still have enough votes to win? Yes, which means, is P3 critical? No, so P3 does not go over there. And one at a time, you'll find that nobody goes over there. Okay, so we've got our list of all the critical players, and I will tell you that this idea of critical player is the toughest thing for this class. It's really, really kind of a tricky concept, so take your time as you think about whether or not somebody is critical, what it means for somebody to be critical. Turn that off. Okay, so here's the next thing we're going to do. We are going to make a count of how many times each player is critical. So looking at our list, you see that there are 6 people that were critical. How many times was P1 critical? Twice. You can see P1 appeared here 2 times. So I'm just going to put twice right here. How many times was P2 critical? Also twice. And P3, also twice. In a very real sense, what do you think about how the power is distributed with these 3 people? That sure looks like it's even. Each of them is critical 2 times, the same number of times. It sure feels like it's an even distribution of power, which I would not have guessed looking at the numbers 10, 9, and way down here 3. So what we do, Lucas actually just mentioned a percentage. What percentage did you say? Lucas says 33.3%. That would be a nice way to talk about power as a percentage. This person has 50% of the power, this one has 40, this one has 10. I could understand percentages. So how do we make them percentages? Well, you take each of these numbers and you divide by the right thing. And the right thing is what number? It's 6. It's the total number of critical players we had. We had 6 people over here in this last column. Another way to say that is 2 plus 2 plus 2 is 6. So we divide everything by 6, which is the total number of critical players. Everybody see where the 6 comes from? Again, there's 2 ways to do it. You either just look at your last column and count 1, 2, 3, 4, 5, 6, or maybe a little bit easier, if you've already found these numerators, 2, 2, and 2, add them up. That's probably the easiest way to do it. And here's the number that Lucas was predicting. This is about 33%, right? 1/3. I mean, it was 100% when you said it as a 33.3 repeating percent. You can leave it as a fraction. You can write it as a percentage. Either way is fine with me. Okay, so this thing that we just did has a name. In fact, the name is the part of the section heading right here. This is the Bonzoff Power Index. It's named after a person, that Bonzoff. So the Bonzoff Power Index is this whole chart with this whole fraction calculation, and finally we get our percentages. That is what he called the power index for the weighted voting system. All right, so this is written up on the next page. It says we define a precise way to calculate the BPI, Bonzoff Power Index. First, we list all the possible coalitions and find the ones that are winning. We did that in the table. And then we find the critical players. That's the hardest part. That was our last column of the table. Then we got to start counting. It says you count the total number of times a certain player is critical, and you divide by the total number of times all players are critical. That was the 6 in our case. So let's see if a second example can kind of drive home this idea, this calculation that we're doing. So we've got how many players in number 12? Actually, I have 4 players in number 12. You can see the quota is 10, and then the 4 people have 6, 5, 4, and 2 votes. And so the question is, how powerful is each person? So you can make a chart, same as we did before. Let's fill this in. We've got coalition, and then I'm not even going to write winning or not winning. I'm just going to put weight. And then we're going to put the critical players. And we're not very creative, so we're just going to label these folks as P1, P2, P3, and P4. Okay, so the only coalitions we care about are the ones that win. So we're not going to write down the losing coalitions. So the first thing that I like to do with coalitions is go with the singles. Is there any single person here that has enough weight to carry the vote by themselves? The answer is no. The coalition is 10. The strongest looking person here is only 6. So I'm not going to list any singles, right? Normally you could put P1 by themselves, P2 by themselves, but there's no point. They're all losing. Now let's look for pairs of people. We did the singles and there's none. So we're looking for pairs of people. Will the 6 and the 5 pass the motion? Yes. So then we're going to list right over here P1 and P2. And how much weight do they have, those 2 people together? That's 11. Are there any other pairs that will pass this vote? P1 and P3, that's the 6 and the 4, which gives 10, which passes. A tie passes. So P1 with P3 gives me just enough votes to pass. Yeah, so we're going to move on to the triples. First, let's see if there are any doubles. Are there any other pairs of people that have at least 10 votes together? So we got P1, P2, P1, P3. Are there any other pairs? P2 and P3, how much do they have? They have 9, which is not quite enough. So there are other pairs, but there are no other winning pairs. So we're done writing pairs now. And now we're going to list trios. And things get a little bit hairy when we list trios. People sometimes have a hard time just thinking about all the different possibilities for the trios. This is where one of these sheets that we skipped over is going to help. If we just temporarily go back to page number 3. Okay, first, some good news. You are going to bring page 3 with you to the next test. You will have this reference sheet with you. What's on the reference sheet? Well, it tells you step by step exactly how to do this Bonzoff Power Index. You first list all the coalitions. It even gives you the formula that we talked about, 2 to the n minus 1. And then you find all the winning coalitions, and then you find the critical players, and it tells you what a critical player is, and then you start counting. How many times was each person critical, and then divide by the right number. So step by step, you will have this with you on the test, and you will also have all this with you on the test. So for example, we are right now doing a coalition with 4 people. We already did all the pairs. Sorry, we did all the singles. I think we verified that no other pairs would work. Here is a list of all the trios. So I'm going to keep this projected here, but maybe you guys can go back to page 7. And we're going to look at just the trios here. And we're going to ask ourselves which ones win. So again, the numbers are 6, 5, 4, and 2. Is that right? Okay, so let's look here. P1, 2, and 3. Is that enough votes to win? We need 10. Yes. So list P1, 2, and 3. That's the next thing in our chart. How much weight do they have altogether? Looks like 15. So P1, P2, P3, 15. Okay, the next one is P1, 2, and 4. P1, P2, P4. Did they have at least 10 votes? Yes, they do. So you list them. P1, 2, and 4. And what's their weight? It's 13. And we just keep going right down the list. P1, 3, and 4. 1, 3, 4. Did they have enough? Yes, they do. We need 10. They have 12. So P1, P3, P4 goes in your list. And then finally, P2, P3, and P4. We need at least 10. Do we make it? Yes, we have 11. So this last trio also goes in your list. So we're starting to get the idea of how we can use this to help make sure we don't miss any coalitions. Okay, and then what's the last coalition that will win? Yeah, everybody together. So you list them all together. Okay, and then somebody just to remind me the numbers here, what are the weights? Wait, yes, they can't both be 12, can they? 11 and 17. Okay, so any questions on finding the winning coalitions? All right, so here's the hard part. What do we need to do for each coalition? Take one out and figure out whether or not they were critical. So I'm just going to do one together, and then you guys are going to do the bulk of this work on your own. So for example, suppose that I come down here. Let's look at this row, P1, 2, and 4. I'm going to do this one with your help, and then you guys will work with your neighbors. So one at a time, we're going to cross these folks off. If we get rid of P1, this is the question, is are they critical? How many points do we have left? 7. Is that enough? No. So without P1, we lose. So is P1 critical? Yes, we needed them there. So P1 is critical. You got to stay in this row and do every person one at a time. So P1 is now back in the mix, and we're going to temporarily cross off P2. How many votes do they have? 8. Is that enough? No. So is P2 critical? Yes, because without P2, we lose. If P2 goes away, this coalition loses. So P2 is critical. It's really kind of a funny game that we're playing here. We ask ourselves, what do we ask ourselves? Did they still win? No. So is this person critical? Yes. It's like the answers are always different. So maybe that's part of the thing that kind of trips people up in the beginning. Who's the last person I need to examine? It's P4. I haven't finished this row until I've done everybody one person at a time. Without P4, how much weight do they have? They have 11. Is that enough to win? Yes. So is P4 critical? No. So that's the answers always change. Is this enough to win? Yes. So is P4 critical? No, we could do without P4. So I'm just going to make a note here. You're not going to write this here, but I'm just highlighting that we looked at P4 and decided they were not critical. Okay, very carefully, you're going to ask in every row, every person, are they critical? You're going to work with your neighbors here. I can be certain that some people at each table have like a really good grasp of this thing, and other people just need a little push. Everybody's capable of getting this, but we got to work together and make sure the people that get it are talking to the people that aren't quite there, okay? So very carefully work with your neighbors and fill in the rest of this table. So we've got our list. And again, this is the hardest part, so really take your time, be patient with yourself as you figure out this question. Critical or not critical is the toughest question for today. So we make our list, and then finally we make our fractions. So we're going to just count how many times each player was critical, and then we'll divide by the right number. So how many times was P1 critical in this whole list? Did I make a mistake down here? P1, 3, you're right, thank you. Okay, P3. That better? Thank you. Okay, so we're going to count how many times each player was critical. So we're looking first at all the P1s. So we count how many P1s we see. There's 3, there's 4, there's 5. Yes? So 5 is the number of times that P1 was critical. And then we do the same thing for P2. Highlight this in green. There's 1, there's 2, there's a third one. So P2 is critical 3 times. How many P3s are in the list? Also 3. And then P4, just once, just down here towards the bottom. Any questions on those numbers? Okay, and then the last thing to do to find this bonds-off power index is to make fractions. Now I'm going to give you a test question like this, and it's going to be very tempting because we've spent a lot of time doing all this to think, okay, I'm done, 5, 3, 3, and 1. But the bonds-off power index is fractions, always fractions, or maybe even easier to understand, as Lucas points out, percentages. So we need to divide each of these things by the right number, and the right number is, I think, easiest to find by adding up all of those numerators. So how much is 5 plus 3 plus 3 plus 1 is 12. So 12 goes down here in the bottom. It's 12 because it's 5 plus 3 plus 3 plus 1. Any questions on the 12? Okay, and maybe somebody can give me an approximation here. 5/12 is about what percentage? 42%. Okay, so 3/12 I can do that. That's 25%. And then 1/12 is at about 8. So this one's around 8%. Okay, so now we can talk about these people and be very precise and say the first person has about 42% of the power. The middle people each have about 20, well, they each have exactly 25% of the power. And the last person only 8% of the power. Are there questions on this calculation? Gary. That's, if you just type into the calculator 5 divided by 12, it'll give you 0.42. And that's 42%. Other questions? Okay. So, we'll come down here. Talks about reading. Talks about how, this is kind of a time-consuming process, and we only had how many shareholders in this example? There were just 4. How many shareholders are there for the Electoral College? So how many, there's only 50, right? There are 50 shareholders, each state plus DC, so there's 51. Can you imagine doing this with 51 players? We did it with 4. Okay, so all right, so clearly we don't want to do this by hand for the Electoral College, but There's computer software out there that we'll look at next class that will just zip the calculations out for us, no problem. And in your book, you'll actually see a table that gives you the percentages for each of the states. And that might be interesting to kind of look at and see how is California compared to Washington or compared to Massachusetts. All right, so we have 15 minutes left, but are there any quick questions before we do the group work? Any questions about the project? Part of the assignment over the weekend was to start reading through. It's a lot of information I gave you on the project, but you got to read through it all to understand what it is and to start thinking about what you want to do.
Was there a packet?
It's at the end of the packet we just finished.
And it has the list of like everything? Okay.
Yes. Okay, so what you're going to do in 15 minutes is this activity called Frontier Power. The activity goes for 2 pages. There's an answer key at the end. So let's see how far we can get. I'll walk around, but talk with each other and see if you can get through this in 15 minutes.